Rational expressions. So there are ways that we can deal with fractions, because fractions are really just a representation of division. We're dividing. We are taking x squared minus 3x, and we are dividing, okay, x squared minus 9. Now, interesting notion here. I have a feeling that is a typo. Is that where you struggled? No? I have a feeling that is a typo. No, it'll still work. It'll still work. I wanted to go another way with it, but you know what? We'll work with what was given. We are not going to divide. We are just going to reduce. All right? If I had a fraction 2 over 10, we know that reduces to 1 over 5. Because this is 2 times 1. This is 2 times 5, correct? And my 2 is canceled. So we're going to do the same thing. What can I factor out of the numerator here in x? And I would have what left? Perfect, x minus 3. And of course, the bottom is what factor?
X plus 3.
Yeah, x plus 3. Absolutely. Now we can cancel out the x minus 3. This is the easiest form, in my opinion, of reducing fractions or simplifying rational expressions. So I end up with x over x plus 3. Now, if, and this has nothing to do with the notes, but math, if I said for this expression right here, x was equal to 7, what would that equal? Don't start squaring 7 and subtract 3 times 7. There's an easier way. If x is equal to 7, what is this? It's 7/10. Do you want to know how I figured that out so quickly? This is the same thing. It's just a reduced version of it. It'd be the same thing as if I threw a 7 in here. 7 over 7 plus 3, 7/10. Right? Don't forget. So if x was 5 here, if we had x equal to 5, what would it be? 5/8. Bam. Why do all that hard work when you don't have to? Okay. All right. Questions? It's simple stuff. It's simple stuff. Here is where it gets fun. Adding and subtracting fractions. What do we know about fractions when we add and subtract them? They have to have a common denominator. You absolutely have to have a common denominator. I will write this down for you. Yeah. It's all right? Write this down. So, what does this tell you? If this is A, and this is B, right? And this is C, expression, and this is D. If I set this up, that would help me add and subtract. Because to find a common denominator between both of them, I have to multiply them together. And it can get crazy. Well, let's do our little shortcut here. All right, A times D. And someone said, yes, I cross multiplying. Have x times x minus 5. X times x minus 5. Now, this sign here is the same as whatever they give you. Okay? So we're going to put a plus here. Next is what? BC, right? All right. Now what? B times D. Now you just multiply your denominators. You got it. And we can say that's 3x minus 2 times x minus 5. All right? That is technically a correct answer, but they want us to simplify that. They don't want us to simplify that. Unless a fox is something like it's a butterfly. You did it one time, I was in the classroom, and said, oh, that's cool, I should use it. Guess what? I've never used it. Terrible. I should. You see the wings, you know, the wings of the butterfly, put something with the antenna, like something like this is fly, I don't know what that's. But, there you go. Now, let's simplify it. X squared minus 5x plus 3, yeah, that'd be okay. 9x minus 6 all over 3x squared. That's minus 15x minus 2 minus 17x plus 10. The only thing I can combine on the top are these two terms, right? So I have x squared plus 4x minus 6 all over 3x squared minus 17x plus 10. Holy smokes, that's crazy. If I did not ask you to simplify it, you technically could have been okay with this because it's the same thing. But chances are when I have to ask you to simplify it, well, that's just simple. Combining like terms and foiling two things together. All right, so we're going to do the same thing here, but now we need to be careful. I can still use this if I'd like, but I'm first going to apply that to these two fractions, get an answer, and then what I get for this answer, I'm going to do the same thing with that fraction, whatever it is, and then this to it, okay? So I'm going to do this process twice here, all right? And for the sake of ease, if you do not want to simplify, you do not have to, unless it's real easy to simplify, okay? So why don't you guys take a minute or two and try and do that. All right. So, now that you got a few minutes to do this, let's do this on the board and see how we did, all right? I'm going to cross multiply. I've got 2x, all right? And then 1 times anything is itself, isn't it? So it's plus x squared minus 2x all over. And now I need to multiply the bottoms. X cubed minus 2x squared. This is nice, and I told you don't simplify it unless it makes your life easier. You're going to have to multiply that fraction now times this one, right? So let's simplify it to make it easier. What's the first thing I can simplify in the numerator? Yeah, I have a positive 2x and a negative 2x. Bang, bang. What else can I factor out now? Doesn't each term in the numerator and denominator have at least 2 x's? Why are you telling me to do that? Doesn't mean you're wrong. It just means you just have an unsimplified answer. So for example, I can literally say I've got x squared, and I can factor out an x squared, and then have x minus 2, can I? Yeah. Yeah. Isn't this a 1x squared? So my x squareds can cancel. So technically, I have 1 over x minus 2. That makes life a lot easier when I have to multiply it times my next fraction. Good.
Okay, but that's so,
Hey. All right. Let's talk about that song. I don't know. So now, here's where you need to be careful. Here's where you need to be careful. This is a negative 3. So when I multiply this times my 3, I've got to make the negative distribute with it as well. So here's a little something that you guys can do. Here's a little something you can do to make it easy for yourselves. Whenever you're subtracting, that's like adding a negative number, isn't it? If I have 7 minus 4, isn't that like adding a negative number? It is. So I'm going to say I'm going to add a negative 3. Now it's going to be a lot easier to remember that minus sign has to be distributed with that 3. You don't have to do that if you remember. It's just a little something. Okay? So now, 1 times anything is itself, right? X squared minus 4. I hope so. Now, I've got to multiply negative 3 times this poo. So I got negative 3x plus 6 all over. Okay, all over when I multiply these two. And I'll leave that as x minus 2 times x squared minus 4. Let's clean this up. Okay? Clean this up. I've got the numerator is x squared, okay, minus 3x I can combine minus 4 and plus 6. That gives me, yeah, that's right, plus 2. Thank you very much. It's all right. When things are complicated, we tend to forget the simple stuff. And you know what? I hate to do this to y'all. That backwards. But let's wait. Let's wait. That's all over x minus 2 times x squared plus 4. Now, I know I said you don't have to simplify. This is good math practice. Because some of you who didn't simplify, you're like, Visca, I don't have an answer that looks anything like it. And I get that. This is simplification at its finest, your children. What does the top factor, what are two numbers that multiply to be positive 2 that add to be negative 3? X minus 2, x minus 1. And the beautiful part about that is what? What cancels? X minus 2 cancels. So now I have an answer here on this Venn diagram, whatever the heck it is I drew on the board. I have x minus 1 over x squared minus 4. That is a completely simplified answer. I know I told you guys you don't have to because I wanted you to get the process down, and that's fine. It looks crazy. If this was on a test and some of you guys did this, I would look at that answer and be like, that is dynamite work, even though I didn't follow it. That'd be awesome. Now, $1 million question. If I look, and I'll do this right here, okay? If I go back to my original problem, and someone says, okay, what's the answer? What's the answer if x? If I said solve this and x equals 3, I had a bonus question. And I said, okay, simplify this fraction, and you did. And then the next question just had this. Solve this for x equals 3. It's what? It's 2 fifths. Because it's the same thing when you put an x equals 3 here. They're the same thing. 3 minus 1 is 2. 3 squared is 9 minus 4. That's 5. Be 2 fifths. But I'm telling you, if I had a bonus question and I just listed this, half of you wouldn't make the connection. Half of you wouldn't make the connection that you already simplified it. You would put a 3 in for all these x's in your calculator up here. And you'd probably still get 2 fifths, but you would do so much unnecessary work, it'd be crazy. Yeah, that's what I do. That's what I do. All right, so not an issue. Game on. Okay, multiplying and dividing fractions. All right. Now, multiplying can be tough. I've got some pretty, I don't want to say complicated, but these aren't small, short expressions that I have to multiply together. But just like any fractions, 2, let's call it 7ths times 1/10, I can multiply those out, get a bigger number, that's 2 over 70, and know that that reduces to 1 over 35. Or if I'm smart enough, I can say, well, tops and bottoms can cancel. 2 goes into itself once, 2 goes into 10, 5, and now without even having these big numbers, I just get right here. Which is the same thing we do when we're multiplying rational expressions with polynomials. So let's start, okay? Does anybody remember? Pick one that I want to factor. Anyone? Okay, let's factor this. Thank you for clarifying. Let's factor this. Can I factor out a 2? Yeah. Stop it. 11 and 21 aren't divisible by 2. I'm going to have to use slip and slide here. With space. Right?
Stop it! Stop it!
We gotta factor each term separately and hope things cancel. You see what I'm saying? So I know that when I multiply to get 2x squared, it's got to be 2x times x. All right? And I'm going to give this one to you. Minus 7 minus 3. Okay, there you go. Without having to do simple science, guess and check. How do I know that works? Because I know 2x times x is 2x squared. That gives you negative 14x. Ooh. Does that work? Because that should be negative, which means this should be positive 3. And That gives you positive 3x. Minus 14 plus 3 gives you negative 11. So the sign should be, Rayanna, the sign should be, Rayanna, the sign should be, that should be a minus 3 and a plus 7. There you go. That's why we check, people. You knew you had that. And I thought you knew that the signs. Did you?
No.
I said Ray. I call you Rayanna. That's so much more prettier. I think I'm going to call you Rayanna for the rest of it.
Ew.
That's not proper English, but I don't care. Neither is Rayanna. So. All right. Let's factor the bottom. What can I factor out of the bottom? Left. I can only take an x out because now I have x squared plus 2x plus 4. There is nothing that quadratic will factor out to be. That's it. It can't factor anymore. What about the bottom right? Two numbers that multiply to be negative 14 that add to 5. 7 and 2. Which one's which? Positive 7 and negative 2, which is nice because we have an x minus 7 here. Uh-oh, that's going to cancel with this eventually. That's what we're trying to do. We're trying to get things to match at the top and bottom, so we just cancel them, just like we did here. This is technically 2 times 1. This is 2 times 5. I canceled my 2's. So we're trying to do the same thing here. All right, now, do you remember the top right? The FB? Didn't we do that before I left, the F and the V? Then F squared, then F times V, then V squared? All right, this is x minus 2 times x squared plus 2x plus 4. If you need help reviewing that, stay after or school one day or lunch, come up and I'll help you with it. And you should remember that. It's one of the things you should remember. So, look at that's the difficult part. What's the easy part? What can I cancel? X plus 7 with an x plus 7. What else can I cancel? X squared plus 2x plus 4. X squared plus 2x plus 4. Anything else? Yep. Anything else? X minus 2 with an x minus 2. It looks like that's it. What do I have left? So x minus 3 over x. That's your answer. Do you know how difficult it would have been to come up with that if I multiplied all those together and then tried to... It would have been insane. It would have been insane. Now, here, my friends, is the $1 million question. Yeah, right. If I would have put a 2 in for all of these x's, for this expression right here, I said solve this when x equals 2. What is that? It's 1/2. And you got that by plugging x equals 2 into here. That's 4 minus 2, which is 1, all over 2, 1/2. You know, in years past, I would make people put in a 2 for that. And I'm like, what do you notice to say? I have to get the calculus or type of way crazy. But I'll give you guys a shortcut. Oh my goodness gracious. Bam! I should be able to do the same thing. But what's one thing I need to do first? This is division instead of multiplication. I cannot cancel tops and bottoms unless it's multiplication. Do what with the who now? With which one? Yes, I can turn this into multiplication by flipping the second fraction. So I have x squared minus 4x plus 4 over x squared minus x plus 1 times, okay, I was going to do this and just multiply the first times the second, but let me rewrite it. It's that times x cubed plus 1 over x squared minus x minus 2. All you got to do is flip the second fraction, not the first. You flip the second fraction in terms of multiplication. All right? Can I factor the top left? Is there anything that multiplies to 4 that adds to negative 4? Yes. X minus 2 times x minus 2. Very good, very good, very good. Can I factor the bottom left? Is there anything that multiplies to 1 that adds to negative 1? That adds to that's a negative 1? There isn't. There isn't. What about the bottom right?
Oh.
X minus 2 and x plus 1. Very good. Now this one is x plus 1 times x squared plus x. No, it's the opposite sign. Sorry. Minus x plus 1. That's this right here. That is that right there. Look at the answer! X minus 2 with an x minus 2. Very good. What else? X plus 1 with an x plus 1. What else? X squared minus x plus 1. X squared minus x plus 1. What do I have left at the top? What do I have left at the bottom? Nothing, so leave it at 1. It's a 1. So that's x minus 2 over 1, which is x minus 2. So what happens if I throw a 5 into this whole big division mess? It's 3. What happens if I throw a 10 in there? It's 8, yeah. Here we go. Let's do this last one. Now, there are 3 different operations that we have to do here. Meaning, I do my butterfly effect, whatever, on the top and on the bottom. Then afterward, this is division, right? That's like multiplying if you flip the reciprocal. So, let's not forget, these are over 1, aren't they? Three times x plus 2. Well, that is 3x plus 6. Okay. Negative 7 times 1, minus 7. All over 1 times x plus 2 is x plus 2. Not bad. It's easy when it's simple. Okay? It's easy when it's simple. Let's look at the bottom. What is 1 times x minus 3? Well, it's just x minus 3. What is negative 1? Don't forget that minus sign goes to this. Negative 1 times 1 is negative 1. All over. What's 1 times x minus 3? That wasn't bad. Let's simplify it. The top here, I can combine these two. I get 3x minus 1. The top here, I can simplify it, and I get x minus 4. So I have 3x minus 1 over x plus 2 all over x minus 4 over x minus 3. Isn't that the same thing? Isn't that the same thing as saying 3x minus 1 over x plus 2 divided by x minus 4 over x minus 3? That's the same thing, isn't it? Just flip the second fraction, like a multiplier. Let's flip the second fraction. So this turns into x minus 3 over x minus 4. Now it's multiplication. And there's nothing I can do besides multiply them out. I got 3x squared. It's minus 9x minus 1x. So it's minus 10x plus 3 all over x squared minus 2x minus 8. That's it.